This video is on the preparation of alkyl halides. Alkyl halides are not very common in nature, and if they are, they tend to be very complex structures. However, alkyl halides are great for further modification, as we've seen in every other functional group that we've made. We've pretty much started with an alkyl halide. Alkyl halides tend to usually be prepared from alcohols, which are readily available, as we know. However, the hydroxide is not a good leaving group. Therefore, we need to modify it by protonation or converting it into a sulfonate, such as a tosylate or mesylate, so that we can replace it with the halide. Protonation of alcohols with halogen acids also provides the nucleophile to the reaction, hence it's an ideal method. SN1 mechanisms tend to be favored in these conditions because, for example, water is a very good leaving group, or the sulfonates are really good leaving groups, and you tend to have these reactions in protic solvents. However, SN2 obviously will happen on primary alcohols, and in these cases, hydrogen bromide and hydrogen iodide work really well, as the bromide and the iodide are better nucleophiles. Whilst hydrogen chloride, you need zinc chloride as a catalyst for any primary and secondary alcohols. Either way, the reactions tend to be relatively efficient. You might be wondering, what about the SN1 reactions when you get elimination reactions as a side reaction? Well, you are correct. E1 reactions do occur. However, luckily to us, double bonds that form in E1 reactions tend to react with hydrogen halides to yield the alkyl halides again. So our side product is being cancelled out by an extra reaction. We won't worry about this type of reaction though until next semester. Sometimes protonation is just not possible. Maybe there is a double bond that we can't expose to a strong acid, or maybe there's a functional group that is reactive with acids. Maybe there's a base in there. Either way, if protonation isn't possible, we use sulfonates instead. The first step will involve converting the alcohol to a sulfonate using, say, a tosyl chloride in pyridine, followed by the source of our halogen in an aprotic solvent to give us our product. There you have a go. What would be the product of this following reaction? You may pause now. And here's the answer. The only downside of using tosylates is that it requires two steps. One step to form the tosylate and the second step to do your substitution. And now that we've covered the more complicated methods, we can now learn the easier one-step alternative. For chlorides, we can convert an alcohol into an alkyl chloride using thionyl chloride, SOCl₂. This is a very clean reaction, as the side products are both gases, and therefore it's easy to purify the product. You have a go. What are the products of these following reactions? You may pause now. And here are the answers. Now, thionyl chloride is limited to the chloride. So if you need a bromide or an iodide instead, we need to use PBr₃ or PI3. as seen here. Note that PCl3 or PCl5 can also be used for chlorides, but thionyl chloride is preferred because of those gaseous side products. Finally, if you need an alkyl iodide, you can make those from alkyl bromides and alkyl chlorides by using sodium iodide and acetone. We've encountered this combination of reagents as a test for alkyl bromides and alkyl chlorides, and you should realize that all we are doing is replacing a halogen with the iodide, and the subsequent sodium halogen salt is not soluble in acetone and hence forms a precipitate. Either way, if we mix, say, this alkyl halide with sodium iodide and acetone, we will replace the bromide with the iodide in relatively high yields. You have a go. What is the product of this reaction? You may pause now. And here's the answer. And now, just for review, what are the products for the following reactions? You may pause now. And here are the answers.